Good morning, folks. Working on the Atlas 10-inch lathe again. And I'm starting to do the layout for the collet closer and the collets. This lathe was always intended to be a collet lathe. I was going to put a hand collet closer on it. That's been the plan from the very start. I have a 900B collet closer. Here's the handle. And it's in the condition as I got it. Now I'm going to sandblast it off and powder coat it in the gray that I'm using. This is the rest of the assembly here. And for those of you that are not familiar with it, these are the collars that go around the closer right here. And if we were looking at it from the top, your headstock would be here. This portion butts up to what would essentially be the spindle. Your collet closer goes on here like this, and the adjustment screws lock into this collar here. So when you pull the handle inward, what happens is, in this condition right here with it running, everything's spinning free with the spindle and with the collet in the closed position. This will be spinning along with it. There's two clutch levers or clutch dogs inside here. When you pull the handle forward, what you're essentially doing is you're releasing those dogs. They're expanding into the larger portion of this portion of the closer, and it's releasing this portion and your hand wheel, so it'll no longer spin while the rest of the assembly continues to spin. You can change your piece, or you can advance your piece if you have a draw tube on here up through your collet, and then when you release it again, why that will once again lock everything in position, so everything will turn and it draws the collet back in, is the way it operates. It originally had, well, it does have a drawbar in it, which is not hollow, so you can't feed things through, which tells me that this closer was on a second operation lathe where they just had a small part. Probably they released it, took out the part that was in there, put a new part in from the inboard end of the lathe, released it, and then they did whatever operation they were going to do there. I'm going to change this out. I'm going to turn it into a draw tube, and I've got a piece of 4130 tubing from my airplane projects here. 3/4 inch OD. Internal dimensions on 4130 are nominal. Actually, external dimensions are too, but usually they're pretty close. But internal and wall thickness are kind of nominal. This is actually supposed to be a 63 thousandths ID. That varies a little bit, and I think there's going to be enough material. I don't have collets to put on here yet to fit that up to, so I won't cut that and cut the new draw tube until it's done. So anyway, there's the basic collet closer. Now, mounting this on the lathe, I found virtually no information on it. I did find one lathe that had it set up, or a picture of a lathe that had a collet closer set up on it, and it looked like the mounting brackets that mounted it into the lathe itself were mounted off of the back gear bracket on the outboard end. So if you look back, or if you look at a parts list, and I'll show it when I tear the lathe down to install it, or to design that, why there's two bolts through. One is the top bolt extends farther out the back of the lathe, and the lower bolt is inset some. I think that's probably the way I'm going to mount this on the vertical countershaft, and I don't know if that was a mounting specific to the vertical countershaft, or if that's just a design someone came up with. When you look at most of the drawings, they show the bracketry for that hand lever mounted on the guard mount, which bolts to the back of the bed, or clamps to the back of the bed and holds the guard, and then there's a stud that comes off of that. I think I'm going to mount mine on the counter, or on the back gear. I talked to Clausing. They have virtually no information. They don't even have drawings for it to be able to reference. So I'm kind of going by this is a one-off application, so I guess as long as it works, I can do whatever I want there. So that'll start happening. I'll have to lay that out and design that next, and start building the bracketry for that. I've been asked a couple of times about why I haven't run a test indicator down the bed and measured bore and that type of thing. The reason I haven't done it, and I haven't done it intentionally, is because it's kind of one of those chicken or the egg things. Which do you do first? Now, this is always going to be set up as a collet closer. I didn't know what style of collets I was going to use, or exactly how I was going to set that up. There was some question to me of how the spindle had been mounted in in the headstock itself. There's quite a bit of shims on one side of one of the bearings, and there's no shims in the other side. So something's been done to that over the years, which is not surprising. Whether there's a lot of wear in there yet or anything, I honestly don't know yet what the tolerances are going to be for that. And I had no real accurate way to measure that was going to give me a true indication of the accuracy that I was going to get with this lathe. Now, it's going to do 99.9% of its work within the first inch and a half, probably, of the collet, end of the collet. So in that inch and a half, tolerances can probably run a little bit looser than if we were running it on a 54-inch bed lathe. And the degree of accuracy you get out of your machine is kind of dependent on what kind of accuracy you're requiring. And I'm hoping that I'm going to get enough accuracy out of it that I don't have to go back and rebab at the headstock. If I have to do that, that'll be a project down the road, and we'll do that. But since all of these parts were put together parts, and we don't really know where anything is alignment-wise, without having the collet setup already installed in it and measuring off of a test bar in the collet setup, why there's no real way for me to measure run out or wear in that's going to give me an accurate measurement, or what we're going to get for tolerances or alignment on the tailstock with the headstock. So alignment through the carriage I don't think is as big an issue, and in reality on the production tailstock, alignment is not going to be that big of an issue because that will be addressed with tooling and the way the tooling's set up for the most part. If we're drilling, tapping, those kind of operations, most of those will be done in a adjustable tool holder anyway, so we can address alignment issues there. Most of the tooling that will be installed in that tailstock is going to be adjustable for tolerances that we're going to cut. So those are all going to be overcome. Alignment with the headstock parallel to the bed I don't think is going to be that big an issue. We didn't change anything on those bearing surfaces themselves. So basically that's going to be the way it came from Atlas, no matter what components we install. Even though the headstock doesn't match the bed, they're going to be relatively close in alignment. So I don't think that's going to be an issue. I think it's, if we have any real issues, it's going to be alignment with the spindle parallel to the tailstock, and in alignment with the tailstock vertically, both vertically and horizontally, but especially vertically. The way I'm going to try and cut down on those tolerances or get the most accuracy I can out of it all is I'm going to tear the lathe apart again. We're going to take the spindle out, and I'm going to take that spindle and clean it up real well, obviously. But when I set it up for the collets, since I'm taking the time to do it, I'm going to build a adapter for both 3AT and 3C collets. So I have the option of either one. That may very well require me to build an extra drawbar for the collet closer, but that's not an issue either. That's not a big project there. So I don't have collets in yet. I'm going to get collets for both of those. And what I'm going to do is I'm going to take the spindle, clean it up, get everything as it should be, and then we'll set it up in the Sheldon lathe to the most accurate I can get it, and then we'll very carefully align it, and we're going to build 2 collet adapters for that. And when I build those collet adapters for it, I'll pre-turn those so we have our Morris taper on there to fit into the spindle. Once those are installed, then the headstock will be, or the spindle will be aligned, and both in the forejaw and farther out on my roller steady rest, and then we'll bore the spindle adapters for both a 3AT and a 3C collet, and we'll bore them so we've got alignment in the spindle, and then one way or another I'm going to index them if they're changed out into that spindle so that the collet's going back into in the same way it was. That is the most accurate way that I have available to me to get the most concentricity out of those components that I can. So that's the path I'm going to take. That'll be happening over the next few weeks here. I've got to gather up some collets, and I want a variety of collets because I'm hearing about a wide variety of tolerances on both 3C and 3AT collets. A lot of the collets will be import collets, I'm sure, if I'm buying new collets, or you know, as I run across some used collets. So of course I'll grab them, and I want a few of them here before I start machining those components, just so I can kind of average what's going to be there and see what kind of accuracy we're going to get out of those components. So then hopefully when we assemble that all back together, why we'll have pretty good alignment on that. Then we'll start checking how we are for accuracy and what kind of tolerances we've got in that headstock and on that lathe itself. So that's why I haven't addressed that before. That's why you haven't seen a test indicator set up on there, because like I say, I could set one up, I could run a few different tests and run some things, but in reality they're kind of redundant. They don't really tell me anything that is going to do me any good at that point in time. So we'll proceed as we go along. So that's kind of an update of what's happening. I'm going to go ahead and start designing the components. I'll probably go ahead and powder coat up this handle for the lever for it, and we'll get that much cleaned up and ready to go, because there's not going to be any wear or fitting to the handle itself. These are the components as I got. I did have one little bronze or brass bushing that came with this collet closer, and of course this collet closer has been well used and abused. I did not find where this fit. And the only thing that's come to mind all of a sudden as I've looked at it here on the bench this morning is it may very well be a bearing surface for this hand lever. So that may get incorporated in. The later collet closers that Atlas offered, which was a 6630, was the later collet closer. The collet closer is virtually the same. The handle design and the mounting is a little bit different. It's got a yoke system over the top of it here, rather than a stud sticking out. So anyway, we're gonna start alignment of this and see how it lays out. I've got to do something with the gear guard on the end. Originally, I believe these had a two-piece gear guard. I've seen a couple of them that I believe go to this. I was hoping that I could at least come up with drawings for those so I could build patterns and recast those, even though it's basically a one-off operation. What I may very well do is take a standard guard, or take the standard guard that I've got, and there's a couple of ways I can do that. I could either split a guard and make it into a two-piece guard, which is not original, and the idea being the top portion of that guard is permanently fitted so that the lower portion, so you can still access the gears and everything, are there, and then bore out the upper section. For now, since I'm still just setting it up and not worrying about change gears for speeds and feeds yet, what I may do is I may take that gear guard and just bore it out so we have a bigger hole going through it, so we've got clearance for the collet closer itself. So anyway, that's kind of the latest update. If you got any questions, leave them in the comment section for me below. And when I've got some machining stuff or some layout stuff to show you, we'll show you another portion of this build. So anyway, if you find these videos helpful, you might want to hit that subscribe button if you haven't already. If you hit the bell notification, you'll know when I put out a new video. And any comments or suggestions you've got for me, leave them in the comment section below. Thanks for taking the time to watch, guys.